Hi, everybody, and welcome back. So this is we're about, I guess, halfway, little over halfway through the course now, and we understand how R thinks about data structures, and we also understand a little bit about doing reproducible reporting and also building figures and graphics. But so far, everything that we've worked with has been data that we have created directly within R, or it's a data set that already came in a package, like the MPG data set or something else. Now, at this point, we actually want to figure out how we can get our own data or data that we're really interested in from the computer or from the internet into our studio so that we can start working with it. So the review of last time, we talked about basically just all about non-atomic vectors and non-atomic vectors that are non-rectangular, i.e. lists, just like this string or set of ordered values that could be any sort of class, lots of different classes, or a rectangular non-atomic list, i.e. a tibble, so something that looks a little bit like a Microsoft Excel spreadsheet, something like that. And then we talked about how we can use different subsetting rules. We can subset by column position, by row position, a combination thereof, that we can use negative positional subsetting if we're using named indices. We also talked about the intricacies of extracting the cell or a set of cells from these tibbles and lists versus the contents of those cells. And a lot of times people will make the mistake and they will extract the component of their data that they need, but they don't know how to get into that data to get at the nice juicy bits, so the numbers themselves, if you will. So it's difficult to do math with that. Um, so we talked a lot about the different ways that we can subset these tibbles and these lists. Now, in this lesson, we're going to talk about how we would actually go about reading in some raw data, particularly CSVs and delimited text files using some delimiter. Maybe it's tab delimited or white space delimited files. I want to talk about what tidy data is. And then we're going to wrap up the lesson with an aside on something called the pipe operator, because we will need it before we go into the next lesson, which is data manipulation with dplyr. So this lesson is sort of a preparatory lesson. It's going to be a little bit shorter, but it's going to be super practical. So hopefully we're doing well, and let's go ahead and dive in. Okay, so before we get much further, I want you to remember why we're doing what we're doing. We're talking about reproducible data science. And a lot of times you can tell someone, oh, here's my data, I performed a t-test. But that doesn't give them the steps necessary, all the pieces in the middle about how the data and the files were prepared and made ready to perform that t-test. And so we're going to, whenever we import data, the first time we're going to show how to use the point and click interface in RStudio. But every single time that we do that, the point and click interface will actually write some code for us. And we're going to absolutely make sure that we save that code to a script so that we can share with others our workflow, share with others our process, so that our process is for our own selves pre-producible and then for other people reproducible. More information on this chapter is in the importing data chapter of the R for Data Science textbook. I strongly recommend that you go and take at least look through the topics that are in that book. I decided to focus on two different data files or types of data that you're going to interact with most often, and that's going to be the .txt file, which is like a tab delimited data file, and .csv file, which is going to be comma separated values file. There are a lot of other different ways that you can interact with data. I know that the CDC and the Department of Health and Human Services overall really likes SAS transport files, so SAS 7 BDAT files. A lot of times you'll still see Excel workbooks. You see Stata files. I think those are .sav files, maybe. There's a lot of different ways that you can get data out of these other softwares. I'm going to recommend, though, if you're working with SAS or Stata or SPSS or something like that, or even Excel, save your data as .csv files. .csv, the dot comma separated values files, those are basically universal. Almost every computer in the world can open a .csv file one way or the other. Many computers cannot open a SAS transport file like .sas7bdat or .sav files or even .xlsx files or .xls files. Those are Microsoft Excel files. So when you have the option to export data, try to go with a .csv just because it's going to work basically the same almost on any computer on the planet. So that's just a quick comment, and that's why I'm going to focus on showing you how to deal with .csvs and .txt files, the tab delimited files. So we have an example. Let's say that we're interested in, and maybe by the end of the semester, interacting with food stamp usage in Miami-Dade, Broward, and perhaps Palm Beach County, so South Florida. And we can get data from the CDC or from the Department of Health and Human Services or the census, the American Community Survey, that is for the entire state of Florida. But it's difficult to get data. Sometimes it can be challenging to get data specifically by county. And let's say that we wanted to perform some kind of analysis where we're comparing Miami-Dade, Broward, and Palm Beach counties against the rest of the state of Florida, maybe because these counties had different policies, different procedures in place during, I don't know, the COVID pandemic or during whatever, so that we're going to see, well, did these laws that went into place in the 3 counties in South Florida have an effect on whatever it is? This is a pretty standard type of question in epidemiology where you say, okay, well, these counties had a particular law in place, these other counties had a different law in place. Let's just do kind of like a case control sort of matching thing. Say, okay, well, there's 63 counties, I think it's 63 counties in the state of Florida. So let's compare the counties that had this to the counties that didn't, like just averages for these zip codes. And so one of the things that we may want to do is we may want to say, okay, well, let's make sure that we find all of the zip codes for Miami-Dade and Broward County. And then also we want to find data for those zip codes. So the first thing that we can do is go to some online websites that have this sort of information. Here's 2 links that at the time of recording this video, they worked. And you can look at the data for these zip codes. And honestly, what you have to do, you basically just copy and paste the data into a text file. And this is important to make sure that it goes into a .txt file. So .txt, not RTF, not a rich text format file. We don't want to preserve the formatting here. We just want the plain basic information. So you should end up with something like this. So I'm going to pause the video here, and I want you to work on this. I want you to go to these links, and I want you to download the zip codes for Miami-Dade and Broward. And honestly, while you're at it, go and get the zip codes for Palm Beach County. Or if there's another county in the state of Florida that you're interested in, go get the zip codes for that county. Okay, see you soon. Okay, welcome back. So I trust that you were able to find, obviously this is Broward, that's Miami-Dade, and then from these websites, you could probably find whatever other county in the state of Florida that you were interested in. You were able to highlight the rectangular data, copy it, and paste it into a flat text file. It's important that this is a flat text file. So .txt, not any other kind of file, just .txt. And then you should have been able to save it. So I'm going to show you a little bit of what this looks like on my end. So I have a data folder. So this is a project that I have for this class. I have a data folder, and right here, I've got the Broward zip codes.txt and the Miami-Dade zip codes.txt. So when I click on this, this is what I see. These are all the zip codes for Miami-Dade. And this is just very basic flat text information. So here's Broward. And you can see here that the first row is just the column headers, and then all of the data starts on the second row. And here are all of the zip codes for Broward County. Okay. So this is what it should look like. And here is the next huge chunk. This is a really, really big exercise. Okay. So I'm gonna leave this here. I want you to pause this. I'm gonna tell you a little bit about it here. I want you to go get some data from the American Community Survey. And I want you to find the data for, I think this is going to be, what year is this? 2021, I think. 5-year estimates. So this is American Community Survey, so ACS, 5-year estimates in 2021. So it's looking back 5 years from 2016 to 2021, and all about the SNAP program. So Supplemental Nutrition Assistance Program. When I was growing up, it was called food stamps, but now it's called SNAP. So go get the food stamp data for the state of Florida and make sure that you have the geography is a zip code tabulation area. And this is what we want to do, because we want to get data for the zip codes, and then we just got data for which zip codes go in which counties, and then we're going to say, okay, now we're going to figure out like this intersection. Now you may be thinking like, well, why don't I just get data for the county itself? Well, what you want to be able to do eventually is you'd want to be able to make a map that has zip code level or census tract level information within those counties. So you sort of have, like, from a statistics perspective, you have the treated area, which are the 3 counties that you care about. So Miami-Dade, Broward, Palm Beach counties, or if you're in some other counties in Florida, those counties is what you would care about. And then, so you want the counties there, and then you want everything else. But then within those counties, you want to have the ability to have like the geographic sampling areas, if you will. So I'm going to pause here. Okay, so that could have taken you a little bit of time. Sometimes the ACS website is not the easiest to navigate. You will end up with a really big zip folder down here, and then you unzip the folder, and then you should end up with something that looks like this. And then inside of here, so I've got American Community Survey 5-year estimates. I've got 3 data sets. So this is a table notes. This is meta information about the table. This is a table just of what the column names mean. And then this is this is the actual data set itself. The actual data set, if you're on I'm not sure if this works on Windows or Mac. I don't think it works on Mac. On Windows, you may be able to just click on this and it open in Excel, but I don't think so. So you're probably going to have to find it through your, so on Mac, it would be through Finder, or on Windows, it would be through File Explorer. So go ahead and find where this file is on your computer and open it up, and you'll see something like this. Now, I don't normally recommend that you open up these data sets from the CDC, because some of them can be just huge, just monstrously huge. We were dealing with some data sets during the COVID pandemic where the students that were working on the project, their computer would crash if they tried to open up the Excel file, because they had older laptops or whatever. So we ended up having to write some code to help them get around that. So R can like go through and pull out the pieces of information without having to open up the giant file in Excel, because these files had gotten just massive. So I don't normally recommend that you try to open the data set and look at it. But you can see here, this is only 2.7 megabytes. So this honestly isn't that big. And your computer should be able to handle something like this, even if it's an older laptop. So anyway, this is a bit what the data looks like. You can see there's a lot of columns and a lot of rows. We don't know how many rows, how many columns yet, but once we pull it into R, we'll be able to get a bunch of that information. So this is what we have. And we want to get this CSV into R, to get into RStudio. So like I said, I'm going to show you how to use the point and click interface first. But honestly, I think this is a good time to pause. So we'll wrap up this video here. See you in just a minute.